Dear students, today we are going to discuss Overseas Road Note 31, a guide to the structural design of bitumen surface roads in tropical and subtropical countries. Tropical countries are those countries in which we are having the hot climate, and the subtropical countries are those in which we are having the moderate type of climate. Parent fines are the fines developed during crushing of rocks. These are usually 5 mm or less in size. These should be used to fill the voids of aggregate. Macadam developed the design procedure for the construction of pavement. Particle size is 37.5 mm or 50 mm in dry-bound macadam and water-bound macadam. So these are the two typical sizes, particle sizes uh, for the dry-bound macadam and the water-bound macadam. In dry-bound macadam, vibrations are used to fill the parent fines into the voids of gravel. In water-bound macadam, water is used to fill the parent fines into the voids of gravels. This technique gives better results normally to fill the voids. But if the subgrade is clay, then water will reduce its strength. You know, when the moisture content of the clay increases, then there will be drastic decrease in the shearing strength of the clay with the increase of moisture content because of the reduction in the cohesion, or you can say the shearing strength. Now on this particular slide you would see some important information. If CBR is greater than 80%, it means that is remarkable for the base material. So in other words, we can say that for the base material, the CBR value must be more than 80%. If CBR is greater than 30% for subgrade, then subbase is not required as per Road Note 31. If subgrade has CBR less than 4%, then use capping layer. It means the CBR is of not good quality, it's poor subgrade. So in that case, we will have to provide a capping layer upon that weak subgrade. There are two types of surface dressings, single surface dressing and the double surface dressing. Well, here I would like to mention one important thing, that there are three options for the surface course of the flexible pavement. Either we can use the surface dressing, or we can use the flexible bituminous surfacing, or you can say the pre-mixed bituminous material. And the third, which is the most rational one, that is the proper surface course, which will be consisted of wearing course, and just beneath the wearing course we will be having intermediate or binder course. Single surface dressing are normally adequate when applied to a bituminous layer. To be satisfactory for non-bituminous surfacing, the quality of a single seal must be very high, and subsequent minor maintenance must be carried out promptly when required. It is recommended that double surface dressing are always used on a non-bituminous layer. The quality of a double surface dressing will be greatly enhanced if traffic is allowed to run on the first dressing for a minimum period of 2 to 3 weeks and preferably longer before the second dressing is applied. This allows the chipping of the first dressing to adopt a stable interlocking mosaic which provides a firm foundation for the second dressing. If the trafficking results in the contamination of the first dressing with mud or soil, this should be thoroughly cleaned off before the second dressing is applied. Sand may sometimes be used as an alternative to chippings for the second dressing, although this cannot contribute to the overall thickness of the surfacing. The combination of binder and sand provides a useful grouting medium for the chippings of the first seal and helps to hold them in place more firmly if they are poorly shaped. A slurry seal may also be used for the same purpose. Well, keep this thing in the mind that in the surface dressing, what we do, first we spray bitumen on the surface and then small size aggregate is placed upon that sprayed bitumen. So in this way we will be having the surface dressing. Obviously in the double surface dressing you will have to carry out this exercise 2 times. So ultimately you will be having the double surface dressing. Then the next stage for the surfacing is the flexible bituminous surfacing, or you can say the pre-mixed bituminous material which is being used at the top. It is essential that the thin bituminous surfacings 50 mm recommended for structures described in chart 3, 4 and 7 of structure catalog are flexible. We will discuss these charts at the end of this file. This is particularly important for surfacing laid on granular road bases. Mixes which are designed to have good durability rather than high stability are flexible and are likely to have sand and bitumen contents at the higher end of the permitted range. Yes. In areas where the production of sand-sized material is expensive and where there is no choice but to use higher stability mixes, additional stiffening through the aging and embrittlement of the bitumen must be prevented by applying a surface dressing. So far we have discussed the 2 options, surface dressing and the option of the flexible bituminous surfacing. The most rational option for the surfacing is that at the top we are having the wearing course and beneath that we are having the base course or the binder course. Although we are using the term base course, preferably we should use the term asphaltic base course, and under that you can see the road base. This is basically the base course, and then the sub base, and here you can see the subgrade. So starting from the subgrade, you can see that upon the subgrade we are having the sub base, then we are having the road base or the base course, then the asphaltic base course or the binder course, which is also known as the intermediate course, and then at the top we are having the wearing course. So you can see that this surfacing, this is consisted of 2 layers, wearing course and the base course or binder course. Better to use the term asphaltic base course for this. So this is the nomenclature which is being followed in the road Note 31. The design process. There are 3 main steps to be followed in designing a new road pavement. Number 1, estimating the amount of traffic and the cumulative number of equivalent standard axles that will use the road over the selected design line. So equivalent single axle loads or equivalent standard axles are to be determined corresponding to selected design line. Then the next step is assessing the strength of the subgrade soil over which the road is to be built. And the third step is selecting the most economical combination of pavement materials and layer thicknesses that will provide satisfactory service over the design life of the pavement. It is usually necessary to assume that an appropriate level of maintenance is also carried out. So these are the three important steps. Now on this particular slide, you can see the different activities which are to be done. So here you can see the main activities. If I just look at the main activities, you can see that survey possible routes, assess traffic, then measure subgrade strength, select pavement materials, select structure, and then the stage of construction. And you can see that these main activities are associated with some sub-activities which are mentioned on the right side of the slide. And here you can see the equivalence factors for different axle loads. Keeping this thing in the mind that we are studying the road Note-31, so equivalence factor or the load equivalency factor, you can see here this formula. You are familiar with this formula, but look at that. Here the power 4.5 is being used because this is the road Note-31. So axle load in kilogram divided by 8160, that is the standard axle load in kilogram. And look at this power, this is 4.5. In AASHTO guidelines we use 4, but here in the road Note-31 4.5. So by using this table or by using this formula, we can determine the equivalence factor. And you know, the equivalence factor is basically used to determine the equivalent single axle load. Or in other words, you can say that we are going to convert all the axles. We are going to convert all the axles into standard axles by using the equivalence factor. This slide is also very important because on this particular slide you can see that in road Note-31 there are 8 different classes of traffic are being considered. And look at the equivalent standard axles into 10 raised to power 6. Here 0.3 into 10 raised to power 6. This one is 0.3 into 10 raised to power 6. This is 0.7 into 10 raised to power 6. So depending on the design, equivalent single axles or equivalent single axle loads or equivalent standard axles, you can get the traffic class. For example, you have determined the equivalent single axle loads or equivalent standard axles, and that is falling in this range. So in that particular case, you can say that the traffic class is T4. On this particular slide, you can see that we are having 6 classes for the subgrade material, and you can see that the CBR values or the ranges are mentioned on this in this particular column. So based on the CBR value, we can get the class of the subgrade. In fact, in this method, you will have to know the class of the traffic, and you will have to know the class of the subgrade. Once you are having these two classes with you, then the designing of the flexible pavement becomes very simple. Simply you will have to use the design charts, and you can get the thicknesses of the different layers very easily. Now in this particular slide you can see the properties of the unbound material, and look at the codes which are being used over here. GB1A means fresh crushed rock, GB1B crushed rock, gravel or boulders, GB2A dry bound macadam, GB2B water bound macadam, GB3 naturally coarsely graded granular material including processed and modified gravels, GS natural gravel, GC gravel or gravel soil. So in road Note 31 we are using this particular nomenclature or the codes which are mentioned in this particular table. Here you can see the recommended plasticity characteristics for granular subbases, and the granular subbases we are using the code GS. So you can see here the different climates: moist tropical and wet tropical, seasonally wet tropical, arid and semi-arid, and you can see the liquid limit, plasticity index and linear shrinkage. So if you are having the climate of this type, so in that case your subbase must fulfill these requirements. If seasonally wet tropical, then these requirements, and in arid and semi-arid, arid means a very dry climate. That means arid is that one, that area where the climate is very dry. So corresponding to different climates, we are having certain requirements, and those requirements must be fulfilled. Now in this particular slide you can see the properties of cement and lime stabilized materials, and look at the codes which are being used over here: CB1, CB2, CS. CB1 means stabilized road base, CB2 stabilized road base again, and CS means stabilized sub base. But if you just look at CB1 and CB2, there is a difference. For CB1, the unconfined compressive strength in megapascal is from 3 to 6 MPa, and for CB2 1.5 to 3. Strengths, well, here you can see that unconfined compressive strength rests on 150 millimeter cubes. That means 150 millimeter cubes are prepared, and this unconfined compressive strength test will be performed on those special cubes. Now here, guide to the type of stabilization likely to be effective. So here you can see that the type of the stabilization using cement, lime, and the lime pozzolan. Pozzolan should not be a new term for you. It's a type of volcanic ash. Now look at that. There are two, you can say, categories. First is more than 25% passing the sieve number 200, and here the less than 25% passing sieve number 200. So accordingly you will have to use, if the more than 25% passing is there, then in that case you will have to consider this particular part of the table, and if you are having less than 25% passing through sieve number 200, then this particular portion will be considered. So here you can see If the PI plasticity index is less than 10, then you can see cement and lime pozzolan option are quite effective, but lime will not be suitable, or you can say you will not be getting the result of that extent that you're having the case of cement and the lime pozzolan. So in this way you can decide, you will be able to get some guidance about the type of the stabilization. Now this particular slide is very important. Summary of material requirements for design charts. In fact, we are going to use 8 different charts in this road Note-31. You can see for chart number 1 and 2, we are having the double surface dressing. Chart 3 and 4 will be used when we are having the flexible asphalt. That means asphalt concrete had been placed at the top, and when you are having the proper wearing course and the asphaltic base course, then we are having chart 5 and 6. Now look at the description of chart number 7 and 8. 7. High quality single seal or double seal for T4, flexible asphalt for T5 to T8. And chart 8, double surface dressing. And this column is meant for the surfacing. We are having different options: double surfacing, flexible asphalt, or the most rational option that the wearing course and the asphaltic base course both are present. Now look at this road base. This is the base course, and you can see that when you are considering the chart 1 and 2, in that particular case you must be using the road base of these types. If you are using this one, you will have to consider the road base of these types, and similarly you can see the other possibilities which are mentioned in this particular column. At the bottom, RB1 and RB2 and RB3 are mentioned. RB1 means bitumen macadam road base, and the bitumen content is 4 plus minus 0.5% in that case, and RB2 and RB3, that is rolled asphalt road base, and in that case the bitumen content is 5.7 plus minus 0.6. Now on this particular slide, again you can see the traffic classes, you can see the subgrade classes and the material definitions, or you can say the legends which are being used in this particular method, road Note-31. Well, here you can see more clearly the traffic classes. So based on the equivalent standard axles or equivalent single axle loads, you could be able to get the traffic class from T1 to T8, and based on the CBR value you can get the subgrade strength class from S1 to S6. So in this particular slide you can see the material definitions or the different legends for the different materials, and here you can see bold black line which is being used for the double surface dressing. This symbol is for flexible bituminous surface. That means a concrete, asphalt concrete or one layer has been used. And this one you can see that bituminous surface, usually a wearing course and a asphaltic base coat. That means the most rational or the most important type of the surfacing, that is this one. Similarly, you can see the other legends. Now to onward, you could be able to see 8 different design charts. Well, here you can see granular chart number 1, granular road base, and the surface dressing is there. For example, you have decided that surface dressing is to be done at the top, and you have got the classes of the traffic and the subgrade, and let's say the traffic class is T3 and subgrade class is S3. So this is T3 and here S3. So it means this is the cross section of the pavement. And here you can see the thicknesses of the different layers which are given in millimeter. So it's very simple. Simply you will have to use one particular chart, and with the help of the classes of the traffic and the subgrade, we can determine the thicknesses of the different layers of the flexible pavement very easily. Look at this one. This is the chart 2, composite road base, unbound and cemented, and again the surface dressing is there. Here in the chart number 3, you can see the granular road base, semi-structural surface. Semi-structural surface means we are having the concrete, asphalt concrete surface. So pre-mixed concrete, asphalt concrete surface, which is being used at the top. So this is treated as semi-structural surface. Again, on the next chart, chart number 4, you can see again composite road base, semi-structural surface. Semi-structural surface means pre-mixed bituminous material has been used at the top. And here chart number 5, and you can see the granular road base and structural surface. When we use the term structural surface, it means we are having the wearing coats and the asphaltic base coats. Both layers are provided at the top. So as I have mentioned, that this is the most rational approach for the important highways. Now if I just look at this chart, let's say the traffic class is T7 and the subgrade class is S4. So T7 and this is S4. So it means this is the cross section of the pavement. So you can see the thicknesses of the different layers. Now if you just look at the footnote which are given at the bottom of the chart, here you can see the note 1 and the note 2, and you can see that up to 100 millimeter of subbase may be substituted with selected fill. Selected fill, that means a material of good quality. I will repeat this one. Up to 100 millimeter of subbase may be I will repeat this one again. Well, if you just look at the chart number 6, This chart is again showing the composite road base and the structural surface. And you can see that if the traffic class is T7 and the subgrade class is S4, so in that case this will be the cross section of the pavement. If I switch over to this one, again this is the chart 7, and you can see bituminous road base or semi-structural surface. Semi-structural surface means we are having the asphalt concrete layer at the top, just one layer. And again, by using the same method, we can determine the thicknesses of the different layers. While we were discussing the footnote, if I look at the footnote again, this one, so here is very important footnote is that up to 100 millimeter of subbase may be substituted with selected fill provided the subbase is not reduced to less than road base thickness or 200 millimeter. So this note should also be considered because on some chart we are having this note, so this option can be exercised. I will discuss this fill material in more detail at the end. Well, if you just look at the last chart, this one you can see here the cemented road base and surface dressing. Simply surface dressing is being used. But methodology is same, simply you need the traffic class and you need the subgrade class, then you can determine the thicknesses of the different layers very easily. Now here in the last slide you would find some detail about the fill material which can be placed upon the subgrade, and in this way you can reduce the thickness of the subbase. So title is Selected Subgrade Materials and Capping Layers as per Road Note 31. These materials are often required to provide sufficient cover on weak subgrades. They are used in the lower pavement layers as a substitute for a thick subbase to reduce costs. The requirements are less strict than for subbases. Well, this point is very important. A minimum CBR of 15% is specified at the highest anticipated moisture content measured on samples compacted in the laboratory at the specified field density. This density is usually specified as a minimum of 95% of the maximum dry density in the British Standard Heavy Compaction Test, in which we use 4.5 kg rammer. In estimating the likely soil moisture conditions, the designer should take into account the functions of the overlying subbase layer and its expected moisture condition and the moisture condition in the subgrade. If either of these layers is likely to be saturated during the life of the road, then the selected layer should also be assessed in this state. Recommended gradings or plasticity criteria are not given for these materials. However, it is desirable to select reasonably homogeneous materials since overall pavement behavior is often enhanced by this. The selection of material which shows the least change in bearing capacity from dry to wet is also beneficial. Thank you.